Hello and hi everyone. My name is LUBNA SOFEA binti ZAIDI.
And my name is AFIDA binti REZU from Unit BM1. Today, we want to present our project product for subject MTES 3352.
For our introduction, what is PISA? PISA is the OECD's program for international student assessment. PISA measures 50-year-olds' ability to use their reading, mathematics, and science knowledge and skills to meet real-life challenges.
The problem that are chosen from PISA's assessment is car drive. As we can see here, is a speed time graph. As in the question, under the problem, we got two other questions. For question 1, the problem is to find the maximum speed of the car during the drive. Therefore, we need to interpret the graph by looking at the steepest, the highest slope of the graph. Therefore, we can see that 60 km per hour is the highest speed that Kelly can reach. As for question 2, the problem is to find the time when Kelly slammed the brakes to avoid the cats. From this question, we need to understand that Kelly's car got a sudden deceleration. So, deceleration is represented by negative slope on the graph. Therefore, we need to get to the point when the graph is in negative slope. Then, we look at the axis X for the time, and then the answer that we got is 6 minutes past 9.
We move to the other parts of this presentation, which is what is difficulties aspects of mathematical skills and concept consist in the problem chosen. Regarding the problem chosen, information is presented in the form of a graph, a diagram that shows numerical data in a visual form. Speed time graph can be challenging due to their abstract nature and the need to understand the relationship between speed, time, and distance. Therefore, the difficulties aspects of mathematical skills and concepts revolve in the problem is how students interpret a graph. Number 1, students might get misconception between the graph in the problem speed time and distance time graph. The confusion happens because both graphs involve time on the x-axis, which can make them look similar at first glance. Thus, it leads to misinterpretation of the graph, especially if students are not carefully reading the labels on the axis. For example, regarding question 2, what time was it when Kelly slammed on the brakes to avoid the cat? The students might interpret the horizontal line represent that Kelly slammed on the brakes. The student get the wrong answer because the horizontal line shows that stationary object in distance time graph, and in fact the horizontal line in speed time graph shows that the object moved with constant speed. Thus, the right answer is the negative gradients shows sudden deceleration when Kelly slammed on the brakes to avoid the cat.
Number 2, students might misinterpret the graph regarding the unit used for time in the x-axis. This is because the graph is missing the relevant information, making it more difficult to communicate the information effectively, as the graph meaning is unclear without knowing the time scale. For example, Students might get confused to put the time unit either in minute or in hour for the answer. Without a specified unit, the scale of the x-axis is unknown, making it challenging to determine the actual time intervals represented by the graph. Moreover, understanding the motion represented by the graph requires knowing the time intervals over which the speed is changing. Lastly, students might face the difficulty when applying concepts of speed, distance, and time to real-world situations represented by the graph. As in the problem chosen, the graph is plotted based on real-world situation in which a car drives on the road. Without a clear understanding of the context of the motion of a moving car, students may struggle to make sense of the graph and relate it to familiar situations. Furthermore, the graph is not only a simple straight line, making it more complex to understand how changes in speed and time relate to each other and how they affect distance traveled. In conclusion, applying the concepts requires mathematical skill such as calculating gradients, areas under the curves, and interpreting the meaning of these calculations in the context of motions.
We move to the next part, which is type of reasoning. Regarding to the problem, the deductive type of reasoning is suitable to solve the problem. Deductive reasoning is a logical approach that involves moving from general ideas to specific conclusions. Thus, it can be applied to interpret speed-time graph by using logical deductions based on known principles. Regarding question 1, the problem is to find the maximum speed. Students can begin by deductively understanding that an object's maximum speed is the highest speed it can reach while in motion. Then, students may infer that the steepest part of a speed-time graph corresponds to the maximum speed. This is due to the fact that acceleration is represented by the graph slope, and the steeper the slope, the higher the acceleration. Then, by interpreting the graph, students can deduce the point where the slope is the greatest, knowingly that the object's maximum speed is denoted by this point. Lastly, find the point on the graph where the slope is steepest and use the deduction to find the maximum speed. The object's maximum speed is shown by this point.
Regarding question 2, the problem is to find the time when Kelly slammed on the brakes to avoid a cat. Firstly, deductively, students can start by understanding that the car is in sudden deceleration, and deceleration is a negative acceleration indicating a decrease in speed. Then, students need to identify deceleration on the graph where the speed decreases. This is represented by a downward slope on speed time graph. Then, the student need to locate the sudden deceleration given by the slope changes abruptly from a positive value to a negative value, indicating the beginning of sudden deceleration. Lastly, the time when the object is in sudden deceleration can be deduced by locating the corresponding time value on the x-axis at the point where the slope changes abruptly. This time value represents the start of the deceleration phase. Overall, Deductive reasoning can help students interpret speed-time graphs by enabling them to make logical deductions based on the relationships between speed, time, and acceleration.
For the last part, we create a question based on the problem. So, the statement is, one day, LUBNA wants to meet her friend AFIDA by a car. She starts the journey and stops by a gas station. Then, she continues her journey to AFIDA's house. Finally, she meets her and returns home after some time. This is our graph. We make distance time graph.
There are two questions. Question 1. What was the distance from LUBNA's house to AFIDA's house? The student will get full credit if he or she answers 100 kilometers. Then for question 2, the question is to find how long does it take for LUBNA to fill the tank. The student may get full credit if he or she answer the right question, which is 10 minutes.
In conclusion, from our presentation, we hope that everyone will be benefited. Hopefully, our nation's PISA assessment will be more empowered. Thank you.
谢谢 Dr. Fan.